Okay, this is a short primer on the process of linearization. Whoops. The idea here is that we can plot a nonlinear function and make it appear as a straight line plot, and then we can use the Google trendline tools to fit an equation to it, even though it's not a linear function. And I'm going to use this example here. I've made up some x values here in a data table, and the y function I'm going to plot is 3 over x. So to do that, I just click here and I say equal to tell it to calculate. Then I'm going to do 3 divided by, and then the x value that's associated with that row. So I get this, duplicate down, so I have 20 values, make it look a little prettier. Okay, so I have 3 over x, 3 over 1 is 3, 3 over 2 is a 1.5, 3 over 3 is 1, and so forth. Now if I grab all of these and go up to Google Chart, say give me a chart. The chart types we like are scatter, that way you can just see the data points as is. Here it is. Okay, and this is an inverse function as we would expect from the definition over here. The problem is that when we get to this part and we say please plot me a fitted line, I can't plot linear, that's not good. I can't plot exponential, that's not right. I can't plot polynomial, that's not right. So none of the choices that Google gives me for fitting a trend line will work. So what are we going to do? Here's what we're going to do. I'm going to take this function again, 3x, put it 3 over x, and then over here on this one, instead of plotting x, I'm going to create a data table that is 1 over x. In other words, I'm just doing the same thing that this is. In fact, over here, I'm going to rewrite this as 3 times 1 over x to make it explicit. So this is the same function as this thing. I'm just putting this in parentheses. But now instead of plotting it versus x, I'm going to plot it versus 1 over x. To create the 1 over x, I just do equal, and then I come over here to x, and I do 1, whoops, let's make that easier to see, 1 over the x value, like that. So all I'm doing is creating a column that is the same as it's derived from the x values, but I'm keying it off of what is happening here. And I want to make that a little prettier, so I'll do this, a couple of decimal points, there we go. So now I have a column of 1 over x values, and now to create a column of y equals 3 over x, I just say equals 3 divided by, and now, whoops, I don't want divided by. I could put 3 divided by this x over here, but what I really want to do is 3 times, and now I'm keying off of this idea here. This value right here is 1 over x. So I can just do this, and that is 1 over x. And I can duplicate that down like this. Now you see that once I do this, 1, 2, 3, I get the same values here. If I pick any random value, 333, 333, 188, 188. So this row right here, this column, is y equals 3 over x. But instead of plotting it versus x, I'm going to plot it versus 1 over x. So I grab these like I did before, go up to Insert Chart. Now I say chart types, we like scatter, so we go down to scatter. Here we go. And now we're seeing that it's appearing as a straight line. And that's because I've changed this scale here from being, let's see if I can move this off. I've changed the horizontal scale here from being linear like this to 1 over x. I'm still plotting the same function. I'm just making it appear as a straight line. And the beauty of that is that when I say, give me a trend line, I can go down here, and now linear, being one of the choices, works just fine for this. And if I put this on, I see that the equation I get is y equals 3 times x, but the x value is 1 over x. So this is actually a plot of y equals 3 over x. The relationship stays the same. The number 3, That's the parameter or the coefficient in the equation stays the same. It's the same plot. It's just done in a way that makes it straight line so that we can use the limited Google menu here for fitting best fits. That's the story.